Hello everyone, welcome back to our SolidWorks course. In this video, we will be learning how to create templates. Templates are nothing but documents that store the values or the data that you have specified. In SolidWorks, we create templates for parts, assemblies, and drawings. In these documents, we store data or rather the information that is repetitive and we need not change it every time we create a part, assembly, or drawing. Let's move to SolidWorks and understand how do we create a template for a part. You can see here, this is how I have created a new or rather launched. This is how you can see here that I have launched SolidWorks and now I will simply create a new part as usual. For that I can click on new over here so that it launches this tab, or if I want to create it more faster I can simply press Ctrl N on the keyboard and then it again shows me this window over here. In order to create a template, we will first simply open a part by double clicking on it, and once it launches this command over here, we will move ahead and specify all the parts or rather all the information that we want to add to the template. For that, we will click on this gear icon over here. It will take us to the options. From here, we will go to the document properties. Once we are into the document properties, we can edit all these properties over here, that is annotations, dimensions, virtual shapes, detailing, units, model display, and all sorts of things according to what you want in the template. In the drafting standard, first I will let it be into the ANSI drafting standard. Next, what I will do here is that I will edit the units. In units, I will specify a custom unit which would be based on the mmgs. The length would be millimeters. The dual dimension length would be in inches. What is dual dimension is that when you add a dimension and specify dual dimensions from the options, it will add a millimeter dimension and also it will add an inches dimension. That is how dual dimensions have been added. The angle would be specified in degrees, the length again in millimeters, but here I want the unit for grams or rather unit for mass to be in kilograms. Here in the unit for mass, I want it to be kilograms instead of grams. So I will change it and set it to the custom units. The unit for volume should be millimeter cube and the time should be seconds. Once I have set this, we can move to the next option, that is model display. You can specify any sort of the model display you want from over here. I will leave it as it is for now. Next here you can specify the image quality. If you feel that the edges for your models are not proper and are pixelated, you can either increase the image quality over here, and if you feel that your image quality is affecting your file size, that is, it is creating file sizes that are too large, so you can reduce the image quality, but it is always optimal that you keep it over here somewhere in the between. From here you can display the plane display, that is according to this. You can specify the transparency of the plane. For this option I will exit this first. I will click on OK. You can also specify if you want the planes to be shown when you open a part or rather use this template. For that, you will simply select this plane and show it. Now, if I save the template in this format, every time I create a new part by using this template that I would be creating now, the front plane over here would always be shown. For now, I don't want this to be the case, so I will hide it so that everything has been hidden over here. The next option over here that I would be adding is that I would be adding an axis. I will be going to the reference geometry tab. I will clicking on axis over here, and from these options over here I will select the option that says two planes. I will expand this part 5 from over here and I will specify my front plane and right plane as the axis that is supposed to be created. I will click on OK. You can see that we have created an axis along Y direction. Next, again I will go to the axis from the reference geometries. I will create another axis between the front plane and the top plane. Like this, I have selected both of them. They have been added to the selection box over here. I will click on OK and create this reference geometry. I will be doing this for the third combination. Again, I will be clicking on axis. In the selections, I would add the top plane and the right plane. I will click on the right plane and you can see that the third axis is being shown over here. You can see over here that the axis is being shown with a preview. The yellow line shows me how the axis would be created. This is where I referred to the instant feedback given by SolidWorks. You can see it will show you if the axis you're creating is in the proper direction or not. Here I will simply click on OK and generate all these three axes. Once I have added all the axes, you can see here that now they are being shown. I can click on them and hide them if I want. Let's say if I click on them and show them again, as I want them to be shown in my part template. The next option, or rather the next feature that you can customize in your part template, are the appearances over here. Let's say in the background, I want the scene to be plain white. I can set it to plain white because at times it can happen that the background is not matching, or rather it creates confusion between the products due to the visual errors. So I will set it to plain white so that there is no issue with that. Once I have done this, we can move forward and save our part template. Now is the part which is most important. From here, the most important part begins. For that, I will go to File over here and I will select Save As. If I click on Save As, it will ask me what is the file name and what is the file type. First, I will specify the file type over here. I will go to the drop down, and from here I will specify my file type as a template format for the part. Let me look for it. Here it is, part template, that is .prttot. I will select this file format and you can see that it has already changed the directory for the template. Here I will name my template as custom, and once I have added the name, I will click on save, or rather let's say custom part template. I will write custom part and simply click on save. Now that we have saved our template, we can close this. Once we have closed this, that part template would be reflected over here. For that, I will again press Ctrl N, and now you are into the Novice tab, wherein you have been showing only these three default templates. We'll go to Advanced, and in the templates you can see that this custom part is being reflected over here. If I click on the custom part and click on OK, it will open, or rather create a new part in the custom part. I can simply double click on here and it will do the same. You can see here that it has created a new part in the template that we just stored. So it is a good option, or rather a good practice, to create a template which is specific to your customizations so that it enhances or optimizes your workflow. Now that we have created a new part, I will show you a basic process of how we create parts by using features and parameters, that is, feature-based parametric modeling that we had seen in the first video. Also, I will explain you about the design intent. You can sit back and just watch what I am doing so that you get a good overview of how we would be creating 3D models in SolidWorks. First, I can hide these axes so that they don't obstruct my view over here. I will first click on the top plane. Let's say I will click on the top plane, click on sketch, and once I am into the sketch mode, I will select a center rectangle from the sketch entities and I will draw a rectangle over here like this. Now I will get into the smart dimensions by using the mouse gestures, and I will select this line to add a dimension over here. Let's say I give it a dimension of 100 millimeters and I give it a height of say 60 millimeters. You can see the sketch has now turned black, telling me that the sketch is now completely defined. Next, I will go to features over here, and from here I will select extrude boss base. This will convert this sketch into a 3D model. In the preview, you can see this is how the model will be generated. Let's say I want to extrude this for a distance of 15 millimeters. I will enter 15 over here. This is one of the parameters. I will click on OK and generate this extrude. You can see that we have created a 3D model of the sketch. First we created a 2D sketch and then extruded it along the direction in order to create this 3D part. Next, I will select the top plane over here, or what I can do is that I can select any of the faces over here as my sketch planes. For example, if I click on this face over here, you can see that so many options have been popped up. From these, I will select the sketch option. Once I am into the sketch mode, I will begin with my sketching, but before that, I will get into the normal to mode. For that I will press Ctrl 8 on the keyboard and I will select the circle sketch entity. I will create a circle starting from the origin like this. Again, I will get into the smart dimensions by using the mouse gestures. I will press the right mouse button, move my cursor upwards, and then now here I am into the smart dimensions function. I will select the circle and give it a dimension of 20 millimeters. I will enter 20 in the modify tab and press enter. Once I have done this, I have created the sketch over here. Now I will go to features and select extruded cut. Once I select extruded cut, you can see that this is how the cut would be generated. This is the direction of cutting the material, and here we have several options. Let's say I will select through all so that it creates a cut through all of the material over here. I will click on OK and generate this cut. If I press Ctrl 7 and set it into the isometric mode, this is how the 3D model that I have just created would look like. Now you might have seen that I used several dimensions and relations in order to create the sketches. Let's get back to the sketches and I will show you how. For example, if I want to edit the sketch, I will right click on this feature, go to edit sketch, and once I am into the sketch mode, I will press Ctrl 8 on my keyboard and set it into the normal to mode. Now I will show you here what are my parameters. You can see over here that we have two dimensions, that is one, this is the first dimension of 100, and second, this is the dimension of 60. These are the parameters that are controlling my first feature, that is the boss extrude 1 over here. You can see this is the feature that these two parameters are controlling. According to the sketch that we generate over here, the 3D part or the 3D feature would be created in the same way. So let's say I will first clear the screen. So let's say if I edit this from 100 to be 120, I will click on OK and this will change the dimension from 100 to 120. And I make this from 60 to 70. I will click on OK and this is how I have changed the parameters. Now let's take a look what happens when we have changed these parameters and we get back to the 3D mode. I will exit the sketch by clicking over here, and once I have exited the sketch, you can see that now the model over here has changed. I will click rebuild over here, or instead of clicking rebuild over here, I can press Ctrl Q on the keyboard in order to rebuild the part. If I click Ctrl 7, it will set it into the isometric mode, and you might notice here that the plate over here has changed. If you want to verify, I will click on this line over here or this edge over here, and at the bottom of the screen you can see that the length is being shown as 120. Another way of doing is that I will go to evaluate, I will click on measure and I will select this edge over here. The edge over here I have selected is being shown at having a length of 120 millimeters. I will right click and clear the selection. Next I will be selecting this edge over here. You can see I have selected this edge over here and it is being highlighted in green. The length of this line is 70. I hope from this you've got an understanding of what parameters are and what features are, and how features are dependent on these parameters, and when you change these parameters, your features would change directly. Another parameter that is controlling this 3D model over here is the length of the extrusion. For that, I will right click on boss extrude 1, click on edit feature, and we can see over here that we have this extrusion that is created for 15 millimeters. Let's say I change it from 15 to 10 and click on OK. You can see in the preview that it is showing me that it has been reduced from 15 to 10. I will simply click on OK and generate this change over here. Again, I will go to the measure tool. I will select this vertical edge and it is showing me that the length of this edge is now 10 millimeters. So this is how we use several parameters and features in order to create our 3D models. I hope with this small example you've got an idea of how we create features and how do we edit these features and the parameters that are our dimensions and relations that we use to create the sketches. Also, in this video I hope you learned how do you create your customized format for your part file. You can create a similar part or rather a similar template file for your assembly files. It is not a different case, but creating A template for your drawings is a different case. That would be taught to you in the drafting module. You need not worry about it now. I hope you've got a good understanding of how we would be creating 3D models in SolidWorks. That's it for this video. I will see you in the next one. Thank you.